Okay. Hello, everyone. All right, so we're going to talk a little bit about chemistry. Now, what we're getting ready to start really is the biology unit that has to do with cells, and we're looking at how cells functions and things like that. And a lot of people wonder why we spend any time with chemistry, when that's because chemistry is the basis of how cells and how living things work. You know, when we're talking a little bit about macromolecules, talk about proteins, lipids, carbohydrates, nucleic acids. We talk about enzymes. We talk about all kinds of different things. And honestly, none of that would make sense if you didn't have a basic background in chemistry. Now, the other thing is, too, a lot of this is going to be review. We're going to review some basic inorganic chemistry. And you're going to say, oh, man, I've already done this. Yes, you have. And that's great if you remember all that. However, we're going to build upon that. We're going to go a little bit more in depth than you may have in your other classes. And we're also going to go into some totally new territory called organic chemistry, which should be pretty new for virtually everybody that's had science classes. This is not something we get into until biology and chemistry and some other upper level science classes. All right, just to begin with, remember that we're going to start at the very beginning and we're going to kind of build upon that. And so what we're going to start with is we're going to start with matter. Matter is what things in the universe are made out of. And yes, there are different kinds of matter. And when you want to get into the really trippy stuff like dark matter, physics and chem, great class for you. We're going to talk about how matter makes up living things. And to start with that, when we talk about matter, one of the things that we measure is we measure density. Remember that density is mass over volume. Okay? Mass is really the amount of matter you have. Now, I wouldn't be a good science teacher if I didn't mention that weight is not the same as mass. Do we use them interchangeably on Earth? Yeah, sure we do, because there's not really a whole lot of difference. But technically, mass is the amount of matter you have, and weight is gravity's pull upon your mass. So, for example, if we were able to take a rocket ship and shoot you to the moon really quickly, whatever you weighed on Earth, you would weigh 1/6 of that on the moon, because the moon has 1/6 of the Earth's gravity. So, even though you would have the same amount of mass, you would have a very drastic weight loss. Volume is the amount of space that matter takes up. And really, when we're looking at measuring the density, it's a good indicator of how much mass you have in a unit of space. That's really what it's taking a look at. Okay? States of matter. Now, I'm not going to write these in, so you just kind of got to listen for the definition. We have our 4 states of matter. We have solid, liquid, gas, and plasma. Solids have a definite shape and a definite volume. They also have their atoms in very tight, very orderly arrangements that allow for very little space, so those atoms don't move very much. And that's why they get that really hard, solid appearance, and that's why they have a definite shape and definite volume, because those atoms cannot move very much. Liquids have a definite volume, but they do not have a definite shape. And so when we're looking at their atomic arrangement, they're a little bit more loosely associated. So the atoms can actually kind of slip past one another when they're in that state. Then we get to gas, and gas is way, way more spread out than either one of the other two. Remember, solids is really densely and very densely packed atoms. Liquids are fairly dense, okay, but they're allowed a little bit of movement against life. Gases are really, really, really spaced out. Okay, in fact, if we take a very small amount of gas and we put it into a very large area, it will continue to spread to the shape of its container, but it'll actually continue to spread until it's no longer really a gas. It's just these little individual molecules all floating around. Okay, so gas does not have a definite shape, nor does it have a definite volume, and it can completely spread out until it totally disassociates. And then we have plasma. Plasma is kind of a weird state of matter. In fact, it's a very high energy state of matter. We don't find it in nature by itself in very many places. You find it in the sun or in stars, the corona of a star. You find it in the Van Allen radiation belts. We find it when lightning strikes. And in terms of nature, that's really about it. However, there are a lot of man-made uses of plasma. We can talk about fluorescent light bulbs, for example. That's plasma, because we super excite the electrons in that gas, in that fluorine gas, and that is why it gives off light. Neon, same thing. Okay, so plasma, very interesting state of matter. Now, to change states of matter, all we have to do is either add or take away energy. Okay, so that's a very important thing to know when we're talking in phase changes, and that's what phase changes are changes in states of matter.